November. If you've not joined us before, our webinars are run every month as a lunch and learn for anyone who's interested in industrial biotech. All of our upcoming webinars are advertised on our university events page, and Sam will post the link to that events page in the chat now, just for anybody who wants to keep up to date. So for those of you that haven't met me before, my name is Jen Smith. I'm the Programme Officer for IBIC, the Industrial Biotech Innovation Catalyst. And this is a place-based impact acceleration account that's funded through EPSRC, and we're creating we're creating the industrial biotech ecosystem across Greater Manchester, Liverpool and Cheshire to accelerate research out of our Northwest universities and working across the industrial biotech sector to create impact within our region. Unfortunately, our PI and director, Professor Aileen Miller, can't be here today, but she's our great leader, and IBIC is sort of her brainchild, really. And she's based at the University of Manchester, and we partner with Liverpool, Manchester Metropolitan, Salford and Liverpool John Moores. And we also engage with a wide variety of industrial partners through our funding opportunities and events. So I'm really pleased today that we've got Jeremy Shears, who's currently the Royal Society Entrepreneur in Residence at the MIB, so the Manchester Institute of Biotechnology. But before this has held many different roles at Shell, most recently Chief Scientist, for which he led Shell's strategic thinking and innovation agenda to enable the company to thrive through an energy transition with particular focus in biosciences. Jeremy's going to talk us through today about how to take science into the commercial world and how to turn research breakthroughs into commercially viable innovations. So I hope I've got that all right, Jeremy, and over to you. Thank you.
Jen, thanks ever so much for the introduction, and yeah, you got that all perfectly right. Thanks for inviting me today. It's a great privilege to be here. You mentioned IBIC. I think there's huge potential for industrial biotechnology here in the Northwest, and I'm keen to help that progress in any way that I can. And in this role as entrepreneur in residence at the MIB, I'm keen to bring any commercial experience that I might have picked up along the way in my life at Shell, particularly around commercializing technology around the energy transition, such as biofuels and renewable chemicals. So I would like to bring any learnings to the MIB and the broader community, of course. So that means that today's talk is perhaps a little bit different from many of the seminars in this series. So rather than focusing on one particular technology that I've worked on, I want to share some insights around how businesses take cutting edge science into the commercial world. And that's a subject really dear to my heart. I've worked extensively with companies, universities, SMEs, startup companies to develop and deploy technologies over the years. And the route is really straightforward. So what I wanted to do was share some thoughts that might help you avoid some of the pitfalls that can crop up along that journey. So in my first few months as entrepreneur in residence, I've really got to know quite a few people and hearing about what researchers are working on. And it's actually a privilege to hear that spirit of innovation and a desire to make a real world impact from the research that folks are doing. But during those discussions, several key questions keep cropping up. Things like, what does it take to turn a research breakthrough into commercially viable innovation? Why do businesses work with academia? And how do they assess the innovations? Actually, how do I even speak to people in business or the commercial world? How do I frame my vision such that others can understand it and maybe want to buy into it? And yeah, tell me about those obstacles that I might encounter along the way of commercializing my research. So those are some of the questions. So what I want to do today is have a short time talking about why businesses work with universities, at least from my perspective. Then I'll go along to talk about how industry develops an idea, the sort of processes that industry puts in place. And then I'll spend most of the time talking about those processes and how we could use those to accelerate an idea that you might have come up with, or an innovation you might be working on today. So that's the plan for today, and some questions at the end. So let's start off that. Why do business work with the universities? So what is it that they value? And these are the results of a straw poll that was conducted a while ago. Some of these things are, perhaps pretty obvious, like people working with the best scientists increases the probability of success of taking something through to commercialization. Clearly, it's about skills and capabilities, having access to those, but also equipment. And that's particularly the case for industries that want to move into unfamiliar areas. I particularly saw that myself in the field of engineering biology, as that became an important topic in academia. It was helpful to explore with universities what that could mean in practice. Access to university spin-out architecture, that's really strong in the Northwest. So people, many people are setting up companies and spinning those out, and that's often a way that businesses can get a hold of that innovation and work together with the companies to take it forward. But in particular, I think one of the themes that I've always really valued is networks. So working with universities and academia gets access to scientific networks, and even networks of networks, because each of you will have your own network, and that's really important. It also gets access to thought leaders. So those are some of the reasons, and I thought it might be helpful just to give an example of how such a network has been pivotal in finding an innovative solution in a project that I worked on in the past, one that originated in the MIB. Many years ago, I forget how many now, but one of the MIB researchers, and you may know him, David Lays, had read an article actually during his summer holiday about sometimes when jam goes off, it becomes spoiled. It actually smells of kerosene. And knowing Shell's interest in kerosene as a jet fuel, he contacted us, and that resulted in a small research project. And indeed, it showed that the jam did contain hydrocarbons, which was a surprise in itself. So cutting a very long story short, and an exciting story, I have to say, this led to a lot of further work that revealed a whole new family of enzymes, hitherto unknown, that convert organic acids into alpha olefins. So not only was this groundbreaking science, it involved high-profile publications, but it also opened up a new route to an important family of base chemicals. So the alpha olefins can be used for making all sorts of products, fuels, surfactants, and plastics. And then more recently, that work has continued. So Shell and the University of Manchester have a 5-year BBSOC funded prosperity partnership. And the aim of that is to mature the technology to the point where it could be industrially important and viable. So that leads on to the question how industry takes an idea and takes it towards commercialization. I think for many people, commercializing research can actually seem really quite daunting and perhaps even confusing if you've never done it before. Even knowing where to start the journey can be a real challenge. But it's surprisingly straightforward when you cut through all the noise and strip it back to the basics. So let's have a look at some of those thoughts. So when I think of innovation, or the process of innovation, I tend to think of a funnel. So ideas come in at one end of the funnel, and ultimately some commercially viable solutions come out of the other end. Often the ideas come from early stage research. It could be in academia, it could be elsewhere. And it's often said, and I like this, that the research is about turning money into ideas. And we need lots of ideas to fill the funnel. But of course, not all of them will make it through. And that's where we need innovation. And innovation is more about transforming those ideas into commercially viable solutions. But note the funnel I've drawn here actually has a few holes in it, and those can be quite important. So let's have a look in a bit more detail. When I started work nearly 40 years ago, most of the innovations were developed through corporate R&D labs that I had some involvement in. But it's fair to say that the sources of those innovative ideas have grown, and they've very much evolved over the years. For example, university collaborations have become even more important, but more and more these innovations come from perhaps unanticipated areas, so suppliers, startup companies, the supply chain, and national labs. So there are many sources of innovation, and they can be introduced into the funnel at any stage. Hence the holes in the funnel. Not everything needs to go into the beginning and out at the end. So, some things can go in part the way through the funnel, perhaps to support ongoing developments. But also, it's leaky. This funnel is leaky. So some technologies can be licensed out, or they spun out along the way. So that's the concept. But then the question comes up, well, it's all very well having a funnel, but how is this innovation funnel managed to drive those commercially viable solutions? So what's pushing things through the funnel? So I think taking an innovation through the funnel towards a deployment is around making conscious decisions, and those decisions need to be made throughout that process. So this is a simplified funnel that I've shown here, but it always starts with business needs, and the innovation as it progresses through the funnel needs to be mapped against how well it is achieving those business needs. Now the funnel I've shown here has four phases, sometimes called the 4Ds. So discover, develop, demonstrate, and deploy. So basically four ways in which the funnel is sliced as things move through. So the discover phase is often around small scale lab experiments. Perhaps start taking place in a fume cupboard or on a laboratory bench. That leads to the develop phase, so the second phase, where the proof of concept is tested, perhaps in a small scale pilot operation. If that goes well, then the technology needs to be demonstrated at a suitable scale. And this demonstrate phase or demonstration phase is actually the final point that the technology can be tested and assessed before committing to building a commercial plant. And then, actually only then, can the technology be deployed, and deployment is the fourth D in the funnel. It's important to note that each of the four phases has a stage gate at the end, and this is where the technology can be assessed before it moves on to the next stage. And that's important because as you move on to each stage, you can roughly estimate that the cost of the development work is going to increase by an order of magnitude, so a factor of 10. So it may be that a discover phase is I don't know whether £1 million, £10 million for the development phase, £100 million for a demonstration phase, and then £1 billion for a full-scale commercial plant. I'm thinking of something really big here, but just illustrative. It's roughly tenfold. So assessing those at those stage gates is really important. Now, in the early stage, stage gate 1, this can be really quite light touch, but each of the subsequent steps become more onerous, more detail is required. And really the aim shown by this arrow here is to increase the probability of success as it moves through the funnel, and to reduce the risks that are inherent with any innovation, and thereby making it more likely that a commercial viable solution is delivered. Now, I've just shown one funnel here. This is one that I'm familiar with. There are many variants on the process. I know that NASA uses a 9-stage technology readiness level for assessing the state of technology. That's also very good. It's something I'm familiar with. I kind of prefer 4 stages. It's a little bit easier to get my head around the 9 stages, but all these are good. The point is that the readiness of the technology, of the innovation, is assessed throughout the funnel. There are a couple of important caveats that I should point out. As I mentioned earlier, not all the innovations need to enter the funnel at the beginning. So some can occur at later phases, as shown by these green blobs and arrows coming in. The other thing is that's stopping a project. So remember the holes in the leaky funnel, so things coming out at various stages. So that's around, it could be around stopping a project, kicking it out. So, well, actually this is never going to work, so let's stop now. It could be around recycling back to an earlier stage. That's another thing that's necessary. As new information becomes available, it may be that we need to recycle back, and that's not necessarily a bad thing to happen. In fact, it's an important thing to happen. So that's kind of the high level view of the innovation funnel. So now you might ask, how can I use this approach to accelerate my own idea towards commerciality? And let's look a little bit into that. Now let's stop for a moment and think about why it's often difficult to commercialize a new technology. This isn't an exhaustive list I've drawn up here, but there are a few common themes that I've encountered, particularly in the area of low carbon products, energy transition, and especially those involving industrial biotechnology. So some of the things, let's have a look at these. So the first thing is actually we need to be really clear about what is the problem we're trying to solve. So what is the problem worth solving? That might sound pretty obvious, but believe you me, it particularly, and I know this myself as a scientist that is often very close to the science and the technology, it can be quite mesmerizing and therefore challenging oneself, or being challenged about actually what is it we're trying to achieve here can be quite problematic. And the danger is if that's not done properly, you can end up with market misalignment. For example, you might get a technology push. I got this great technology, but actually, does the market want it? So technology push is not in itself a bad thing, but if there's no market pull, then you're probably going to have a bit of a struggle. So you need to balance those things. Particularly in the area, I've encountered this one a lot in industrial biotechnology. Quite often the market isn't willing to pay for the new technologies. We sometimes think that we made a new green technology and we have a clean process and we make low carbon products. But quite often we find that those products are more expensive than the existing ones. And that's okay if people are willing to pay for that difference, but that's sometimes not the case. So understanding what the market is willing to pay is really important. The risks of the technology maturation, so take the risks associated with moving through that funnel, are sometimes not fully understood. And even if they are fully understood, that perhaps sometimes not properly addressed. Don't worry, I'm going to come back and sort of review what we should. I'm not just listing a series of problems here. Let's go in a moment. We'll look at some of the potential solutions. But the problem with this risks not being understood is that quite often the cost, but also the time of technology maturation is underestimated, sometimes quite substantially. And related to that is that often the most difficult stage is this demonstration phase, and I'll come back to this in a bit later as well, where you need to build a demonstration plant to prove the technology. And that can sometimes involve a significant amount of capital investment. You need to build a plant, so that's building the plant is investing in the capital of the plant. And you need to do that to ensure that it works at scale. So with all those things that could derail and have derailed projects, I think a structured approach is required to tackle those. So let's think about that. So it's good that every big idea begins with excitement and ambition. That's right and proper. We need to be passionate and ambitious about our big idea. But without clarity, even the best ideas lose momentum. So I would always advocate that before diving in, it's worth spending time, and this could be a substantial amount of time, in framing the opportunity, framing the space that you're moving into. So take time to frame the opportunities. So the sort of questions are around, it's about that, what is the problem worth solving? What are we trying to achieve here? Where are we now? Let's be realistic about where we are now. What are the success criteria? How do we know that we're going to get to where we want in terms of the deployment of technology? How we know we're going to move through the funnel, and how are we going to get there in the end are key questions. So that's about the opportunity itself. Then there's the bit about the risks. So what are the 1, 2, 3, 4 things that might happen that could kill your venture, could kill the development. So thinking about those in advance is really important, because then you can do the third thing, which is develop a plan to reduce the risks, at least to a level that's acceptable, either to you or your funders or your investors or whoever it is that you're accountable. And that's around designing smart proof of concept experiments to check whether the risk is significant or not. Now, it's really difficult, as I hinted earlier, for an individual, particularly an individual that has invented the scientific breakthrough, to think objectively about this on their own. So it's absolutely essential to bring a few people together, and that's people with technical backgrounds, a range of technical backgrounds quite often, commercial backgrounds, people with operational experience. So things beyond perhaps what you and I immediately are familiar with dealing with. And you need to sit around a table and work through framing the opportunity, identifying the risks, and then putting a plan in place to reduce those risks. So identifying the hurdles or those risks that exist along the journey can be quite a challenge. And that's particularly the case when some of them are hidden, or at least not obvious. And that's why you need these different people with different skills, different understandings during that framing step. And without knowing what those risks are, we're likely to stumble at some point along the journey. So I think a systematic approach can be helpful, breaking the risks into different categories. And there are all sorts of categories that you could use. I've shown 5 different categories here, which have the acronym TCOP. So risks associated with the technology, risks associated with the economic aspects, the commercial aspects, the organizational aspects, and the political aspects. So let's look at each of those categories in turn, starting with technology risk, and that's technology is usually the one for those of us with a science and technology background think of first. We're familiar with the scientific aspects of the innovation. But it's surprisingly common for people to forget to identify clearly and be able to write it down actually, what is their core technology. For example, in the area of industrial biotechnology, is it the more active enzyme we've made? Or is it the way the more active enzyme has been evolved? Or is it the way we incorporate the enzyme into the overall process? So being clear on what the core innovation is, I think, is essential. We then move on to I think is the most fraught question. How do I scale it up? And as I've pointed out here, scale up, I think, is one of the least well understood concepts in maturing and innovation. It's not simply about making it a bit more product, say from going from I don't know, shake flask to a 10-litre fermenter. It might be, but the question is, what are you trying to show in going from that shake flask to the 10-litre fermenter? So it's about understanding how that technology will scale and demonstrating that it can scale. So that the scale that you need to do this at is determined by the specific technology risk that you might be addressing. So, I mean, again, some examples. It might be mass transfer of oxygen, or it might be heat transfer, or it might be product removal, or any number of other factors. So it's more about technical assurance, and different investors might need different levels of technical assurance in order to be confident about the innovation that you're taking through the funnel. So we can talk more about scale up if anybody would like to later. But this is an absolutely key one. It's not just making something a bit bigger. It's the reason why you need to test a technology out at a larger scale. Remember earlier I mentioned the demonstration plant is very expensive, and it's the last time you've got to check that the technology works. So it may be the case that you only need to test one aspect, heat transfer. Maybe you don't need to build a completely integrated demonstration plant. I think the other thing that's worth thinking about is in this area we're really helped by digital technologies coming on stream. So sensors are becoming really cheap. But then you get the challenge of dealing with the large volumes of data that they produce. But if you use machine learning, if you use AI, they're your friends. You can actually get more data these days that can support your business case, and I think that's really quite valuable. So we now turn to economic risk, and here we really enter the realm of techno-economic analysis. It's about asking questions around what's the economic potential? How much does my technology cost? How do I assess that techno-economic potential? And really, where are those pinch points, particularly economic pinch points in the process? I've seen many examples of people that have brought technologies to me to assess, and it's unfortunately quite often the case that people come up with a process, and they start with a starting material, a feedstock, and they're producing a wonderful new product, B, that there's a huge market for. The only problem is that in many cases the product B is actually less valuable than the feedstock, so destroying value is not as uncommon as you might think. So that's why that's a crude example, but the point is a detailed techno-economic analysis is really important. So commercial risk, So this is the third of the five risk areas to look at. Involves exploring the commercial opportunity that the commercial space that we're working in, and how we actually get into the anticipated market. So it's questions around, what is that market opportunity? Who are my potential customers? That it may be obvious, it may be completely hidden. So maybe some market research or some straw polling or surveys there can be really important. Who are my competitors? It's obvious that we need to know who we're competing against, but perhaps a more interesting question is what is it about those competitors that makes them competitive? And that can help us to fine tune our own innovation as well with that understanding. What is my business model? Do I want to license the technology? Do I want to have a spin out company? Do I want to make product B and sell that to the customers? Many different business models there that are available. All these developments will need investors. Almost certainly need collaborators as well. People with different experiences, different parts of the solution. So how do I attract those? What is it about my innovation that is attractive, and how can I pitch that to them is really important. And the final one is how can I navigate this valley of death? So valley of death is something that is unfortunately too commonly encountered halfway through the development process, where it becomes increasingly expensive to show that the process is working. A lot of negative results comes in, and the whole thing falls apart at that stage through lack of funding. And that's very often the case when the demonstration phase of the project hasn't been completely understood. So there are many cases I've seen startup companies building their very expensive demonstration plant, but actually it doesn't de-risk the process, and therefore they've spent a lot of money on something that doesn't add to the forward trajectory of the process. Organizational risk is it's really about having the right people and the right capabilities in place to maximize your chance of success of pushing this thing through the innovation funnel. So the basic question is, am I set up for success? Do I have the right capabilities available? Again, we tend to think of scientific capabilities. It's really important to have engineering capabilities, techno-economic assessment capabilities, commercial expertise to hand. Might need some market research, and if it is a spin out, identifying the chief technology officer and the CEO is really important, and they're very different roles. And the other point is, how do I leverage the existing ecosystem? So perhaps the one I'm working with other university departments, with other universities, perhaps with other organizations and with companies. So it's all about having the access to the right people with the right capabilities, and back to that word network again, need the right network in place. So the final risk category, political risk, might sound a bit strange, but please bear with me for a moment. The political risks associated with novel technologies, especially in the clean, green and renewable space, are absolutely critical. So the sorts of considerations are, how does my innovation fit with national priorities and legislation? I mentioned part of my background is in the biofuel space, and one of the reasons why low carbon biofuels are attractive or required is that there is legislation in place that mandates their use. So without being able to supply those, then a business would have a problem. So understanding the legislation that's in place is absolutely essential. But there are other national priorities that we hear about. So there's a net zero priority. So can we leverage our innovation against that? There's the low carbon story. There's the clean growth trajectory that governments talk about. There's also the role of bioscience in the UK. There's some things that could really help us with our innovations there in taking things forward at a national level. Then they're the regional priorities, and this is really comes to the core of IBIC, of course. So things in the northwest region. Even in the Manchester City region, Liverpool region. So people want in those areas high skilled jobs. They've identified areas that are important to invest in. So again, if you get this right, there are and you swim in the same direction, it can be really quite helpful because it's around creating jobs and skills and enterprise. So things around a couple of things that I'm involved in, being on the board of both of those at IBIC. I've already mentioned the Future Biomanufacturing Research Hub is another one. But being some of these things are political, they can also change. And sometimes that can be helpful and sometimes it can be really unhelpful. For example, if an investment depends on some kind of green premium that a government has put in place to support that, it's not beyond the realms of possibility that law will be repealed at some point in the future. So understanding how those external drivers might change is really important. So the final topic I want to touch on, and it really is only going to be a brief touch here, is around systems thinking, sometimes called whole systems thinking. I'm guilty, and I know other people are often guilty, that we work on point solutions. That's what we do. We go into our labs and we do things, and we think, yes, converting A to B, evolving that more active enzyme, engineering the new biosynthetic pathway into bacterium. But in reality, these pieces are often pieces of a much larger jigsaw. So it's important to understand that bigger picture. So what is the picture on the front of the jigsaw box? Or what things need to align for your particular innovation to be successful? Perhaps who we need to work with, and what are the competing technologies. I've found this bit to be especially the case in the energy system, which is undergoing quite a significant transition at the moment to net zero world. So we see new entry of feedstocks, so new feedstocks such as biomass and post-consumer wastes coming into the system next to fossil feedstocks that have been there for 100 years or so. You have renewable energy coming in, and these are opening up all sorts of opportunities for industrial biotechnology. But how do these new things fit alongside the existing feedstocks? I remember this is a transition. It's not you switch one thing off and you switch another one on. So the kind of energy products is also evolving as we see increasing demands for biofuels. So for driving for powering motor cars, for example, less fossil fuels are required when you use biofuels blended in. There's a strong movement towards sustainable aviation fuel and renewable chemicals or circular chemicals are coming into play quite strongly. So placing these new feedstocks and the new processes and the new products in the broader system, the broader energy system in this case, is absolutely essential. And I believe that developing capabilities for individuals in systems thinking, in collaboration, and in digital technologies. So three of the things that I've referred to in my talk today developing those capabilities are essential to really to progress any scientific and commercial innovation today and in the future. So with that, let me summarize what we've covered today. Take the time to frame the opportunity. That's a good investment up front. What's the problem worth solving? How does my innovation fit in with that bigger ecosystem? Identify the risks that could kill the venture. Develop a plan to address those risks with stage gates and check as you go through. Identify the resources and capabilities that are needed to help, and review and update. An update is a key here. The plan as the innovation develops. So I think commercializing technology can be enormous fun. I've found that to be the case, and I hope you found at least some of what I've said this afternoon to be helpful. But really more than that, I hope that some of you will pursue the ideas I know you have and to develop commercial solutions. So I'm going to stop there and happy to answer any questions or have a discussion about anything.
Well, thank you for that, Jeremy. That was really insightful, and hopefully our community has really got something out of that. So if anyone's got any questions, please pop them in the chat, but or put your hand up if you want to ask it in real life. While we're waiting, Francesco made a point in the chat when you were discussing risk, about a clear example of political risk in the US is obviously the change of stance from renewables to fossils and how that's hampered green businesses. So a clear example of what you were discussing, Jeremy.
I think that's absolutely spot on. You know, funny enough, the US was very consistent in a number of its policies for many years, but then one upset and the fallout is pretty significant.
Yeah, huge. Brilliant. So has anyone got any questions that they'd like to ask Jeremy or any points? Yeah, Maury, go ahead.
Hi, Jeremy. Murray Brown, formerly of GSK, now of Biotechnology. Hi, Jeremy. Good to meet you.
Excellent. Good to see you.
It's a fascinating talk and chimes very well with my experience at GSK in sort of similar areas. One thing I'd be interested in your thoughts are in the sort of the digital area, the digital twins, the AI, ML, predictive modeling area, in terms of whether that can de-risk scale up. I guess I encounter quite often talking to people who would be decision makers for taking things onto the next scale, and the difference between I could make it and I have made it. You know, chemists would always want to see 5 grams of white powder in a vial rather than analytical data that says you can make it. Similarly, in a modeling digital world, the in silico model says, yes, you can do this, but you haven't done something, and how the different stakeholders will perceive those things and how you change the mindset of those stakeholders so they accept a different type of evidence for scalability as opposed to scale up.
Yeah. So I could have this discussion with you for hours. Probably it's a really a topical one. Of course, scalability and the data required for it is kind of one of those things in the eye of the beholder. So different people, different investors have a different view. So there's not a one-shot answer. I am a firm believer that with all these digital modelings and operations that are around, you still need to do these things in practice. So let's just be clear about that. And I think that you were heading down that road yourself. I think though that in terms of reducing risk or understanding a process better comes from having more data about that process. And in the past, that was quite difficult to come by because it was so difficult to send somebody in to an operation, take a sample, go to the lab and test. Now that's really easily done because of all kinds of detectors, and particularly in industrial biotechnology, where you now have genetic tools classic example I worked on here is renewable natural gas, so anaerobic digesters. You can now begin to understand what's happening in there because of the ability to sequence what the things are doing there, and with advanced metagenomics. So it's around generating that data and then using the tools to probe that data. I'm not advocating that the data or the model substitutes for the experiment, just to be clear about that. I hope that answers some of your points, but let's talk about this on another occasion as well.
Yeah, no, that would be great. I agree. I think it de-risks the next stage. It doesn't replace the next stage. So you wouldn't go from a shake flask straight to a 100,000 litre fermenter. But what you hopefully don't do is go from a shake flask to a 10 litre fermenter and then discover that the 10 litre fermenter doesn't work for reasons that you could have modelled.
Precisely. And if I may make one further point, because you did mention one other thing, which is digital twins. I think that those are going to be really important in the future. In fact, I've seen quite a few companies now in their development pathway, as part of that development, insist that there should be a digital twin built during the development.
Yeah, and
it's not something you do at the end.
Dominate conversation, but as well, that concept of building digital twins in the development as it's being developed, rather than digital twin after it's been built of the process, because you can use the digital twin then to tweak your development, your design, as opposed to just understand what you have built.
Yeah.
But I'll let other people with their hands up.
Well, thanks very much. So Francesco, if you want to go ahead with your question.
Yeah. Hi, Jeremy.
Hi.
Hi. I wanted to, out of curiosity, I wanted your opinion. So I feel it resonates with me what you said about the innovation in order to be successful in order to be turned into a product, it needs to have a market, right? There needs to have people wanting it. And I often struggle with, I can imagine these small groups of researcher, of startups. What is the best way for these people to have that sanity check, to collect that market intelligence, that there really is a need for what they're making, and that what they're making is going to be competitive, and is going to, in fact, people are going to want to prefer it over existing options, or it's going to cover a niche that isn't there. So how do we go from the small academic groups, or from the group of people who have the idea, to gather that market intelligence?
Yeah,
in your opinion?
That's a good question, Francesco. And I think that the degree of certainty you need in the answer to that question increases during the development phase. So we don't need to know everything at the beginning, basically. So you can tailor the kind of intelligence that you need depending on the stage through the funnel. And at its earlier stage, when you're not spending much money, a stakeholder group or an online survey, this kind of thing can be quite manageable. Of course, as you get further towards the the deployment phase, you'll need to get some feedback on the product itself. If it is a product, if it's a physical product that you're making, so you need to make some of it and get it out into the market. And that I can think of one particular development many years ago I was involved with, where there was a very tiny impurity that was actually not even detectable, that caused a huge problem in the use of that product, that essentially had to be removed, so it had to go back to the earlier stage. So it's around market research, and that sounds huge and big and expensive, and it is as you're getting perhaps towards the deployment, but in the earlier stages there are lower cost ways of doing that, and there are companies that can, or organizations, and I think even things, organizations like I think Innovate UK may even have some ways of going about that.
Brilliant, thank you very much. So we'll finish. Oh, sorry, Francesca. We'll finish our last question from Alfredo.
Thank you, Jeremy. Thank you, everyone. So I have a question about your interaction with the investors. So you say that it's good to have a team that has also a commercial competence, right? You have, because you have experience. So how important is to have this competence when you speak with investors that are not from your field, to explain in their language the opportunity? And is it easier when you have an investor that is already understanding this specific market, and then maybe in this case you don't need that level of commercial competence because the investor already understands that?
Yeah, I mean, I think you've hit the nail on the head there. But it's about it's who is the investor and what point are they coming from? In my experience, I'm in my past experience, I have been in the investor coming in to invest in something. So I might have very different views and questions around the development from somebody else. So again, it's understanding who these people are. A venture capitalist will have very different set of questions than somebody from a pharmaceutical industry that's looking to invest in a product. So yeah, it's unlikely that any one person within the group will have that knowledge. So that's where bringing in the network, perhaps working with the university department, the university spin out departments, could be really helpful as well, because they often have these commercial skills, or at least are actually a key skill is to be able to interpret the questions.
Yeah.
What is it they're actually asking? So you need to use other people. Don't sit on your own and fester. Is the answer?
Thank you very much.
Welcome.
Brilliant. Let me just double check if we've got anything else in the chat. Deepan has just said, great insights, well articulated. I'd like to point out that the UK's Catapult Network is a collection of national assets set up to help investors, innovators to de-risk towards scale up and commercialisation. And full disclosure, I am employed by CPI, the high value manufacturing catapult. So that's just an FYI for everybody.
Very good. Yep, always happy to support CPI. Very good.
Yes. And then the last one is Jessie. She's just portfolio manager at BBSRC, focusing on industrial biotech. Just for reference, some collaborative R&D grants co-funded by BBSRC and Innovate UK in this area encourage applicants to have work packages dedicated to market research and further commercialisation strategies within their application. So,
gosh,
great.
That's very helpful. That is very
great
helpful.
Advice from everybody there. So,
Excellent.
Fantastic. So that sort of brings us to a close. Thank you again, Jeremy. That's been really helpful. And if anyone wants to look back, we will be putting the talk on YouTube in the coming weeks. Just to finish off, Sam has put the sort of information on our next webinar in the chat. We're just waiting for the further details, but it will be from Dharma Nurse, who's at the Growth Company in Manchester, and we'll be advertising their talk via our mailing list and on LinkedIn, so keep an eye out for that. We've also got, as we've discussed, funding opportunities. So there we've got our funding opportunities available on our website, and the next closing date for those is the 11th of December. So Sam's just going to pop the link for that in. And just to bring to your attention, I think we've got a few students and ECRs on the call. We've just advertised our a new event. We're going to have a careers and networking fair aimed at PhDs through to ECRs on the 3rd of February, and that's going to be held at the University of Salford. So if you would like any more information or to join us, Sam's just going to add the registration link, but please do take a look at that and come along. There's more information on the email.
I'm hoping to come to that myself, by the way.
Yes, please do. Yeah, we're just confirming all of the speakers, so there's more information to come on that. And finally, if you do want to reach out to us about anything, please do contact us at ibic@manchester.ac.uk. But yeah, thank you very much again, Jeremy. It's been really insightful, and I hope everybody's enjoyed. But yeah, please do reach out if you've got any questions or queries.
Super. Thank you very much, everybody.
Thank you very much, everybody.
Bye-bye.